Today we're going to continue on with the rational root theorem. We're going to be going into the part 2 where we're actually going to find each of the factors that actually do work. So the first part was just listing out all the possible factors. Today we're actually going to see which one is the right factors. And so again, this is a reminder of where we left the problem yesterday. And so we found out the list of the possible rational roots down here at the bottom is positive and negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 1/2, and positive negative 3/2. But what we're going to do is we're going to actually find out which of those factors work. And there's a couple of different ways to do it, and I'm going to teach y'all with the factor theorem to help narrow down the list, and then we'll go into simplifying it. Today we're only going to be dealing with the rational factors. We're not going to be worried about the imaginary. Just realize that those can happen as well. And so to check those. So our that problem, just kind of restating it, we had 2x cubed plus 5x squared minus x minus 6. We came up with the list of the possible rational roots. This is where we're going to tie back into what we've done the previous days with Descartes' rule of signs. We're going to see how many positive root changes do we have, how many possible positive roots and how many possible negative roots we have. And so what we're going to be doing is to determine the positive roots. We leave it the signs as they are currently in the problem. And so I start with positive and then go to negative, so I have one sign change. So I have one possible positive root. Then we're going to do the same thing with the negative roots. But before we can do the negative roots, we have to think about how we'll plug in a negative x and change things. So since this is cubed, that's going to make this sign change. Squared, the sign doesn't change. To the first power, the sign changes. And our constant, the sign didn't change. So we had, going from our negatives to positives, we had a negative. We switched it over to two positives, and we went back to a negative. So I had two sign changes. And so I count down to 0. And then based upon our power, we have to go down to the even right below it. So we have 2 or 0 imaginary roots. Now it comes into play the factor theorem. So the factor theorem says that if I plug in a number into the polynomial and it comes out with 0, then that root will create a factor. And we'll be using that calculator to help us evaluate. So what you'll do is you'll type in the number and then hit Control var, which is the button right above 9, and then you'll hit the X, which is one of the white buttons at the bottom, press enter. And what we've done is we have now programmed in that number into our calculator. Then you're actually type in the equation and then press enter. And so we're going to type that equation in and then press enter. And we're actually going to type in the equation just like you would see it in the calculator. On the equation. And so I'll show you a picture of what that looks like here in just a second. And so when you're typing this in the calculator, you will type in the equation just like what you see here. You type it fully in as an equation. This is actually showing you a couple of steps into it. I've already typed in the 1 store x, but this is how your calculator is going to look. And if you go back and you select the equation, so you get, after you type in the -2 store x, you go up and highlight what I have highlighted and press enter. You don't have to retype it each time. That's the reason this is a useful tool for this process, is you're getting to use that equation each time. If you're actually retyping it each time, then I would just type in the number. So we're going to do this, and we've already determined that we have one possible positive root. And that's where I would start, because I know for certain I'm going to have a positive number. So I'm going to start by testing out my positive numbers and seeing what I come up with. So if I test out a 1, I end up getting a 0. And since I only have one possible positive, that means I don't have to test any of the rest of these. This is where The Descartes rule of signs is helping shorten our work. So I only had to test that one. Now I'm going to test my negatives. And when I test -1, so now I'm going to be testing out my negatives. I know that if I end up with 1, I'm going to have 2 because it says I have 2 possible negative. But I could have none of the negatives work and I could end up with imaginary solutions. Today we aren't really going to be working on trying to find out what those imaginary solutions are. Just realize they can exist. On Monday of next week we'll start adding some imaginary solutions as possible. So when I plugged in the -1, I got a -2. When I plugged in the -2, I got 0. So that means this one works just like what this one did. And so that means I'm going to have, because it says I have to have 2, I have to have it even set up on. That means my next one is going to have to be, I'm going to have another one of these negatives that's going to work. So if I get through the list and I don't have 2 that work, that means this one gets used twice. I don't know for that for certain, but it could be a possibility. So realize any of these could appear more than one time. That's when we have the multiplicities. So -3, when I plug it in, I get -12. -6, I got -252. -1/2, I got -9/2. And -3/2, I got 0. So here's my other one that worked. So I had 3 that worked. My degree was 3, so that's the most I could have had. And now I'm going to come back and figure out what it is when I factor those. So when x equals 1, I have to subtract 1 from both sides. We're going to find out what the factor is, and that's going to be x minus 1 equals 0. That helps me figure out what I'm putting over here on the side when I'm dividing. So we're going back to the division that we were using those boards for at the beginning of the week. And so a 2x cubed is going to go here. I'm going to divide, and that's going to give me a positive 2x squared. Then I'm going to multiply. And that gives me a negative 2x squared. So negative 2x squared plus something is going to equal 5x squared. Well, that's something I need to add is 7x squared. And if I add those two, then I end up with a 5x squared. So now I need to divide. That gives me 7x up at the top. It's positive. And then I'm going to multiply. That gives me a negative 7x. And then I would add. So negative 7x plus something is equal to a negative x. And that something is going to be a positive 6x. And so I'm going to go to the next one. Divide. And that gives me 6. 6 times negative 1 is negative 6. My next spot is my remainder column. But I have negative 6 plus something is equal to negative 6. So I don't have a remainder. And in these cases, you should never end up with a remainder. So what this means is my function could also be written as x minus 1 times 2x squared plus 7x plus 6. So let's go one more step further in the factoring. We're going to see if we can factor out this. So I need to take one of my other two factors. I had the x equals negative 2, and I have x equals 3 halves. I'm going to take one of these two, and it's going to give me the factor to go over on this side. And I'm going to take the easier one. I'm going to take the x equals negative 2. So that'd be x plus 2. Remember, when we move it over to equal 0, that's the way it looks. I am going to show you this. This is going to show us what our answer should be. But no, you do not have to multiply this one out and solve it. I'm showing you this because tonight for your homework, you may end up with one of the problems where you'll need that process. So I had x plus 2 is the one I want to use. And remember, I am working with this factor, trying to simplify it down further. So I have 2x squared now. I'm no longer using my original equation. I'm using the one that's right there. And on this one, you could have factored it by hand as well at this point. And so I'm going to divide, and that gives me 2x. And I multiply, and that gives me 4x. 4x plus something is going to equal 7x. Well, that something is 3x. Divide. And I end up with 3. 3 times 2 is 6. 6 plus something is equal to 6. And that would be 0. And so my remainder is 0. This factor matched this factor. Oops, I had a... Oh, that's because this would just be a negative 3/2 there. So that's the reason it's off signs. And so we have our factors, this completely factored out version of that equation that we started off with, which was 2x cubed plus 5x squared minus x minus 6. When we completely factor that down, these are the factors we end up with. And so when you have these, sometimes I'll ask you to completely factor it out. Other times I'll ask you for the roots. When I'm asking for the roots, what I'm asking for is this step when it was equal to 0. If I'm asking for the factors, what I'm asking for, where I'm asking you to factor it out, I'm asking for you to write it in that form. So the roots is talking about where would it cross the x-axis. The factors is talking about what would you multiply. What would the factors look like that created that. The next thing I want you to do is I want you to work, and this is going to be one where you get to check it with the computer. And you're going to work out the problem f of x is equal to 2x cubed minus 5x squared plus 4x minus 1. Work through this, check it with the computer, and then y'all will get to start on your homework.